Okay, so we are going to continue with the last question that we were doing. So this is collisions in 1D momentum, conservation of momentum. Okay. So what we did before was we'd looked for V1 prime, and this was our V1 prime equation. Sorry, my bad, you can't see that. So there's your V1 prime equation that we had already completed. Then we found out kinetic energy, and this was our kinetic energy formula, got rid of our halves and solved for it. And then we subbed in the V1 prime into this part right here. And this is what we end up with when we expand my V1 formula. So I'm going to continue with that. Okay. So the next thing that we're going to do is we're going to try to clean it up slightly. Again, we're following steps, simple steps. Here we go. 0.4394, which equals to Okay. So it's 0.26 times 1.69. What do you get? Again, 0.4394. So how do you know you've done the equation properly? If those two are equal, you know you're on the right track. If they are not, then you're not on the right track. For an equation, for a example where one object is stationary and the other object is moving. Okay? All right. 0.26 times 1.5. 0.39 V2 prime plus 0.33 times 0.26. 0.085 V2 prime squared. 0.0865. God. Great. We can't even agree. 0.086. Okay, fine. 0.086 plus 0.15 V2 prime squared. Okay. Now what we're going to do is we're going to bring this over to this side. So this and this will cancel each other out, correct? And you're left with 0, which equals to negative 0.39 V2 prime. Plus we're going to add those two together. What do you get? 0.236 V2 prime squared. Actually, I don't have the answer. I know, but the textbook is not as clear and as simple and as it goes. They're not, sometimes they're confusing. Basically, what I'm trying to say is I'm better than the textbook. Okay. Okay, so we are at 0, which equals to negative 0.39 V2 prime plus 0.236 V2 prime squared. Now what do? That's correct. I factor out the V2 prime, so I get V2 prime, which leaves you with 0.39 negative plus 0.236 V2 prime. Okay? And what happens to this V2? What is that? What is the value of that V2 prime? No, but I just took out the V2 prime. Right? Because they're both the same. V2 prime squared and V2 prime squared can be added together. It's like saying one apple plus another apple equals to 2 apples. Right. Yes. Yes. No, let's not take out the negatives. Okay, so this V2 prime is 0. Now this is one of my roots, correct? This is one of my, and you're doing roots right now in math. Okay, so this is one of my roots. So I know for some people, this becomes, oh, that means the whole thing is 0, because if this is 0, it multiplied by the whole thing, and everything is 0. Well, no, it's not. Okay, this is one of my roots. So first V2 prime equals to 0. Then what we do is we equate this part to 0. Equate it to 0. We don't multiply it by 0. And what you end up is you get 0, which equals to negative 0.39 plus 0.236 v2 prime. Bring it over to the other side. 0. Negative, so negative becomes a positive, divided by 0.236, which equals to v2 prime. So 1.653 meters per second. So there's your v2 prime. Now we haven't solved the equation yet. We're not done yet. We are not done yet. Okay, goodness gracious. Yeah, only. Oh my God. Okay, so we go back to our original equation, and our original equation was v1 prime. v1 prime, which equals to 1.3 minus, what was it again? Minus 0.577 v2 prime. So what we're going to do is now we're going to sub this in here. So this is 1.3 minus 0.577 times 1.653. And what do you get for your v1 prime? So 0.35 meters per second. So the first ball will have a velocity of 1.65 meters per second. Second ball will have a velocity of 0.35 meters per second. This is collision in 1D so far. Only 1D. We still have to do 2D. Okay. And here we simplified it by only making one of the objects moving. The other object was stationary. We are saying one ball was stationary, the other ball comes and hits it. It's just like a pool table. Now imagine if both the balls are moving together and they hit each other. So that's a different situation that we still have to look at. So welcome to momentum. If you want to cry, I have lots of tissue paper. I feel for you. Thank you very much.